Fusion Mobile, quality e-learning experience on the go.
Okay, you're welcome to another session of biology, and for this we'll be looking at pollination. I remember my humble self, Oshitogun Olajide, aka Smoking Brain, and this program is power-packed and brought to you by a Fusion Mobile e-learning platform. Now them be the best. Okay, so basically we'll be looking at pollination, and we'll also be looking at the following outlines: the meaning of pollination, the types of pollination, the conditions which aids the types of pollination, and the characteristics of wind and insect pollinated flower. So the first question is this: what is pollination? Now, you know, right from your primary school days down to your secondary school days and up until now, you've been taught just one definition, and that definition holds water till date. Now, pollination is the transfer of pollen grains from the anther to the stigma of a particular plant, or from the anther to the stigma of okay, let me take it again. Pollination is the transfer of pollen grain from the anther to the stigma of a particular plant. It could be the transfer of pollen grain from the anther to the stigma of just one plant, or the transfer of pollen grains from the anther of one plant to the stigma of another plant. However, when two plants are involved, they must be closely related. You don't just pick plants that are not closely related. No, you pick plants that are what? Closely related. Now, there is something that is also worthy of note. Pollination precedes fertilization. Now, before they get to come together and exchange virtues, the sperm coming for the egg, as in humans don't undergo pollination, but plants basically undergo pollination. So before the ovules comes in contact with the pollen grains, pollination has to precede them. Pollination creates a platform. It's like the bed for sexual intercourse. Now that's the way it is with plants. So pollination is a transfer of pollen grains from the anther to the stigma of a plant. From the anther to the stigma of a plant. From the anther to the stigma of a plant. What then is anther? What is a stigma? Now, an anther is usually a 2 to 4 lobed structure. It's something like this. An anther is usually a 2 to 4 lobe structure. It could just be 2, it could be 3, or it could be 4, but it can't be more than 4, and it can't be lesser than 2. It's a 2 to 4 lobed structure. It contains the pollen grains. Now, inside this is what we call the what? The pollen grains. The pollen grains. The pollen grains is actually in humans we have sperm for male. In plants we have pollen grains for male. So the pollen grains is what the male plant drops on the platform of sexual intercourse. As if sexual intercourse can actually be used for plant anyway. So pollen grain is the structure that houses, the anther is the structure that houses the pollen grain. The stigma is actually how do I define this? Okay, now the ovary houses the ovules. The ovary houses the ovules. But the channel to the ovule, the passage, this is the ovary, the ovules are here. But the passage to the ovule, the passage is what we call the what? The stigma. The stigma is like the gate. It's time to tell you that you can't go in, you have to pay your dues. Now, after all dues have been paid, the door becomes open, wide open. Then you can now penetrate. The pollen can now penetrate the ovules, and the seed will result. Again, pollination is the transfer of pollen grain from the anther to the stigma. It could just be one plant in question, anther to the stigma of one plant. Or, however, if a plant does not have stigma, it has anther. That means the plant has to associate itself with another plant that has stigma. However, they must be closely related. Are you with me? They must be closely related. Now, I'm briefly going to be looking at the types of pollination. There are basically two types of pollination. One is self-pollination. Self-pollination. One another is what? Cross-pollination. Self-pollination, one another one is cross-pollination. Now let's quickly look at the root word, or the word preceding every other word in these two different types of pollination. The word self talks about being adequate, being independent on your own, not depending on other people, being self-sufficient, like you can make it on your own, you can survive on your own, you have all it takes to survive in this world. While the word cross talks about you depending on other people, you are lacking. You need somebody to compliment you. You need somebody to share your thoughts with. You are in depression. You need somebody to make you laugh. Now that talks about what? Cross-pollination. They don't have it all. So basically they need help. They call for an helper. They need housemaid, as the case may be. But for self, they have all it takes to survive. So basically, even as we will be looking at it in-depthly, I'll be saying some terms that might tend to like throw you off, but I'll try as much as possible to put simplicity to it. But take note, for self, we don't need any other person. We do it on our own. For cross, we are calling for help. Can you kindly help us? So that's what we're going to be looking at. So I'm going to draw a table and we'll look at the differences between self-pollination and cross-pollination. Okay, so now we'll be looking at the differences as well as looking at the definitive fact for each of the types of pollination. As I've said earlier, there are basically two types of pollination, self-pollination and cross-pollination. And as I've said earlier, self-pollination is the transfer of pollen grain from the anther to the stigma of the same plant. While cross-pollination is the transfer of pollen grain from the anther of one plant to the stigma of another plant. So we're going to be looking at the differences, or basically speaking, the comparison between them. Now, self-pollination takes place only. Self-pollination takes place only. That means if this factor is not there, it can never happen. Self-pollination takes place only in bisexual plants. Only in bisexual plants. What are bisexual plants? The word bi talks about two. The word bi means two. Now, the word sexual means what? It talks about reproductive structure. So, bisexual plants are plants that have two reproductive structures. Now, what are these two reproductive structures? They are the male reproductive structures, and they are the male and the female reproductive structure. Now, imagine me now, I'm actually a plant, so I'm standing before you. On my right hand is my male reproductive structure. On my left hand is my female reproductive structure. I have all it takes to survive. All I need to do is for this to come here, and both of them they will cleave, and I'll start reproducing. That's all. But one of the major, one of the major disadvantages of having both the male and the female plant on one plant is this: every species that you tend to give birth to will just be the same as you. There is no new intake of ability. Now, imagine a particular plant in my neighbor has this ability, this special ability. That's my neighboring plant. And I myself, I have this ability. It's also special. But don't you know, it would have been better for me to like combine my own ability with my neighbor's ability. But because I have both the male and the female part here, I don't need to look outside. I don't need to search for anybody. So all I do is just cleave the two together. And when I reproduce plants having the same ability with me. The same. There's no difference at all there. So instead of, now for cross-pollination, this is what happens. Instead of them, for some organisms in cross-pollination, they have both the male and the female. For some, they have just the male only. So those ones that have the male only or the female only, they are called the unisexual plants. Unisexual. Unisexual plants are plants having only the male reproductive organ or only the female reproductive organ. However, bisexual plants are plants that have both the male and the female on one plant. Both the male and the female on one plant. Both the male and the female on one plant. So if I'm a unisexual plant, I have to go outside and look for somebody that would complement me. Since I'm a guy having a male reproductive structure, I have to go and look for a female having a female reproductive structure. Then what do? We cleave our abilities together. My own ability and our own ability will join together, and the plant that will come forth would have what? Different variety. We have variation. We have different ability. Probably it could be ability to bend this way, bend that way, or to do stuff that I myself cannot do. So let's look at it critically. Self-pollination takes place only in bisexual plants. Bisexual plants are plants having both the male and the male and the female reproductive structure or organ on one plant. In other words, you can call them what? Hermaphrodite. Hermaphrodite, just like your pawpaw. Hermaphrodite. They have both the male and the female reproductive organ on one plant. Now, cross-pollination. Cross-pollination takes place in both unisexual. Unisexual means they have only one reproductive structure on one plant. Now, reproductive structure could either be male or it could either be what? The female. Now, unisexual plants having only the male, they are called staminates. Unisexual plant, okay, that's okay. I don't want to go too deep. Let's stay on the show. Unisexual plants have just one reproductive organ. It could either be male or female. While bisexual have both male and female. So cross-pollination occur in both unisexual plants and what? bisexual plant. Now let's come down to the second one. For self-pollination, only one parent is involved. Just that plant is involved. That's all. They can survive on their own. Only one parent is involved. Only one parent is involved. For cross-pollination, 2 parents are involved. They have to go outside to look for somebody that would complement them. Now for the third one, it may occur without an external agent. It may occur without an external agent. It may occur. It may. There is tendency that it can happen. There is tendency that it will need an external agent, and there is tendency that it might not need an external agent. But you cannot safely say that it doesn't need any external agent. It is not, it cannot occur. It may. There is tendency that if external agents are not there, it will go on to completion. And there is tendency that even if external agents are there, it will still go on to what? Completion. So it may occur without any external agent. What are external agents? External agents are from the word are agents from outside. They are not agents from inside the plant. They are agents from outside. Examples are insects. Examples are winds. Are you with me? When insects come around and they help you carry your part of your reproductive structure from here, and they want to drop it at the female part, that is what we call external agent. They help you. They help foster the movement of your reproductive structure. They help foster the movement of pollen grains from the anther to the stigma. So that's why we call them external agents. They are not agents from inside. They are from outside. They are environmental agents, as the case may be. Now, why for this one? It requires an external agent. That means if external agent is not there, nothing is happening. It requires an external agent, e.g. insects and wind. Insects and wind, they are required. The fourth one, it does not ensure new varieties. As I've said earlier, all the organisms I will be giving birth to, they have the same ability as me. There is no difference there. So basically, it does not ensure new varieties. Well, for this one, it results in the formation of new varieties. And lastly, pollen grains are effectively utilized. Pollen grains are effectively utilized. There is no wastage. Take note, the male and the female part, they are on one plant. So there is no wastage at all. All I need to do is, I know the amount of pollen grains I will pass to this place, and that's all. Why for this one, there is wastage. Why is there wastage? Because external agents are needed. Now, when insect is carrying pollen grains, some of them will drop on the floor. Some will drop on the fertile ground, and some will drop on the ground that is not fertile. So when it drops on the ground that is not fertile, it is what? It is not useful, so to speak. It is wasted. Are you with me? But the ones that get to the permanent side, the one that gets to the stigma of the female, the one that gets to the stigma of another plant, those are the ones that are utilized. So I take it again, it occurs only in bisexual plant. It occurs in unisexual and bisexual. One parent is involved, 2 parents are involved. It may or may not. It may require an external agent. This one, an external agent must be there. Now here, it does not ensure new varieties. New varieties are ensured. For here, for this particular one, pollen grains are utilized, well utilized, while here some are wasted. So now we will be looking at conditions which aids self and cross fertilization. Okay, so now we will be looking at conditions which fosters, which aids, which support self and cross pollination. As I said earlier, there are basically 2 types of pollination: self and cross. Self-pollination and cross-pollination. So what are the conditions which favor self-pollination? One is homogamy. Now what is homogamy? Now let's try and break down the words into biscuit and banana. Homo and gamy. Now we are not after the gamy or whatever, we are after the homo. Homo means at the same time. Homo means having one type. Homo means following same path. Homo means happening simultaneously. So the word homogamy here simply means it's a kind of situation where the male and the female parts mature at the same time. The male part is known as the anther, the female part is called the stigma. When the anther and the stigma mature at the same time, when the anther and the stigma ripens at the same time, we'll call them what? Homogamy. Now if in a particular plant, the male and the female parts are on one plant and both of them mature at the same time, what will be the end result? Both of them can actually cleave together and pollination will take place and fertilization, that's all. So that's what we have to do with homogamy. Homogamy supports self-fertilization. Now what is cleistogamy? Now there's something we call cleistogamous flowers. Cleistogamous flowers are flowers that never open at all. They are flowers that do not open at all. So in cleistogamous flower, this is what happens. The anther or the pollen grain is deposited on the stigma, and both the pollen grain and the stigma will ripen at the same time. So it also supports self-fertilization. What are those factors that support cross-fertilization? Is what we call dichogamy. Dichogamy is the opposite of what? Homogamy. For homogamy, both the anther and the stigma are maturing at the same time. They are ripening at the same time. For dichogamy, the anther ripens at a different time compared to the what? To the stigma. The anther ripens before the stigma, or the stigma ripens before the anther. But both of them cannot ripe at the same time. What I'm trying to say is this: is either the anther matures before the stigma, or the stigma matures before the anther. But both of them cannot mature simultaneously. They cannot mature at the same time. So in a particular plant, okay, let's assume that I'm the plant and I have my male part and I have my female part, and the male part is matured, the female part is not matured. What will I do? I will just go outside and look for a female counterpart, and that explains the issue we even see in homes. You know, funny enough, human behavior can actually be attributed to plant behavior, because you see some people they get married 3 years, 4 years, and no issue at all. What will happen? They go outside and they look for somebody that is suitable and befitting for them. So in that nature, they are what? Exhibiting dichogamous behavior. A plant having male and female plant, one is mature, one is ripening, one has result, the other one does not have. What will happen? This particular one goes outside to look for a particular plant that will complement it. And so that's what we call dichogamy. So dichogamy is basically divided into two. One protandry and, okay, we've got protandry and I'm trying to remember the second one. Protandry and protogyny. So what protandry and protogyny. So the word protandry here talks about the male part maturing before the female part. For protandry, the anther matures before the stigma. For protogyny, the stigma matures before the anther. And now let's look at the other one, unisexuality. Unisexuality, or unisexual as the case may be. As I said earlier, unisexual is actually a plant that has the male part only, or that has the female part only. But there are some extreme cases that we tend to see. And what are those extreme cases? We have monoecious and dioecious. Now, dioecious is a plant that has only the male part or only the female part. When a plant has just the male part, it is dioecious. When a plant has just the female part, it is dioecious. But when a plant is said to be monoecious, what are they trying to say in that essence? A plant is said to be monoecious when it has both the male and the female part on one flower. When it has both the male and the female part on one plant. And that's what monoecious are talked about. So lastly, and this also favors what? Cross-fertilization or cross-pollination as the case may be. Lastly, we have self-sterility. There are some plants that have both the male and the female part, but they are programmed never to cross-fertilize. If they do it, the plant dies. The plant will not be able to survive. The plant withers and the plant dies. And now, looking at it, on a normal day, a sister and a brother are not supposed to copulate. And when they do, we call it incest. Now, one disadvantage is this. It's not that when they do, they cannot probably reproduce. They reproduce, but the offspring they will give birth to is going to be very, very weak. And as time goes on, they might not even survive and they die. And so the same is even applicable to plants. Self-sterility. There are some plants that have been programmed not to mate together. They have been programmed to always look outside for help. So when they try to mate together, what happens? Along that they die. So that's what it is. So plants that are self-sterile, like your tea plant, they are self-sterile. What they do is they go outside. Or no, they keep going outside to look for mates. They don't do it within themselves. Despite the fact that they have the male part and the female part even on the same plant. But they don't do it that way. They move outside and get their counterpart. And so that's all about conditions that favor self and cross-fertilization. As I've said it earlier, homogamy and cleistogamous flower, or cleistogamy as the case may be, they favor self-fertilization. Dichogamy, unisexuality and self-sterility, they favor cross-fertilization. And never forget these words, protandry and protogyny. It might be a nightmare to you before now, but now I'm sure it's clear. And so now we'll be looking at characteristics of wind and insect pollinated flower, which happens to be our last outline for the day. Okay, so now we'll be looking at the differences as well as the characteristics of insect pollinated flower and wind pollinated flower. Insect pollinated flower. Insect pollinated flower. Example, insect pollinated flower, also known as entomophilous. Also called entomophilous flower. insect pollinated flower. They are called entomophilous flower. Entomophilous is actually has a root word called entomology. Entomology is the study of insects. Entomology is the study of insects. So when you see entomophilous, it means insect loving. The word philos talks about having strong affinity, strong love, strong greater attractive force. So entomophilous flowers are flowers that love attracting insects. So they are insect loving. While wind pollinated on the other hand is what? Anemophilous. Anemophilous flower. Now those are flowers that love wind. They love attracting wind, and they move in the direction of wind, and they stay in a position where wind can get to. And so I will establish the fact that entomophilous flower are insect pollinated flower, and anemophilous flower are wind pollinated flower. I will then move on. Now, insect pollinated flower are flowers that are brightly colored. There are flowers that are adorned. Like when you get to see them at the bus stop, or when you get to see them from afar, you cannot but look at them. Now, because of them, you decide to just most times you stumble across probably you get to see a lady, as case maybe. So you get to see her on the highway, and you're probably not going the same way she's going. You're not going in that direction. But because of the way she's dressed, you just cannot say no, and you just tell her, where are you going to? Now, wherever she's going to, that's where you're going to. It will just change drastically. And now why? Because they are what? Brightly colored. Insect pollinated flowers are brightly colored. No matter where the insect is, the insect will just sense the brightly colored flower, and the insect will go after it. Now it's just like the way the Pharaoh goes after Israelites. They will just keep pursuing them. They will keep pursuing them. That's what it is. So they are brightly colored. They are brightly colored. They are well adorned. They are brightly colored. Wind pollinated flowers are usually dull. Their strength is not in the brightness of their flower. And that's one thing. This stuff is actually applicable to life. You just have to know where you belong. You just have to know your ability. You just have to know your capability. Now, wind pollinated flowers are usually dull. Their strength is not in the beauty of their flower. No, their strength does not lie there. So another point is the flowers of insect pollinated plants, as the case may be, are usually large and conspicuous. Now, the word conspicuous talks about clearly seen. It is visible. You see it from anywhere. They are large. Large simply means having greater size. They are large and conspicuous. And they stay in a place that you just get to see them. You just cannot pass by without looking at them. Why for wind pollinated flowers? Their flowers are small and inconspicuous. They are not clearly seen. They are not visibly seen. And they are smaller inside. There is presence of scent. They are scented. They are scented. These ones have natural perfume, and they don't have to go to ShopRite, Just Right to get perfume. No, they have natural perfume. That perfume is actually an invitation to come. And when they spray their perfume, and the plant sends, the plant is like, this should be probably Miss Paris 2017 edition. There's a way it is. And when those plants sense it, they come towards it. So they have scent, natural scent, not artificial, and not the one we tend to spend hours in front of mirror trying to get it. They have their own natural scent. As a matter of fact, even chemicals are gotten from the flower part, and they are actually used in the production of our perfumes. And most of our perfumes, they have natural stimulant, they have natural effect. They are gotten from a natural source, plant, so to speak. So there is presence of scent. Why for wind pollinated, they have no scent. They are scentless. They don't have anything to do with flower, coloring flower. They don't have it. They are straight to the point. They have a target, and you get to see their target at the end of the day. Now, their pollens are rough and sticky. Their pollens are rough, very rough. They have rough edges, and they are sticky. Like when you touch them, they stick to your hand. And before you know, probably maybe you're trekking from a particular place to another place. Once you get there, you notice and you drop it. So that's how it works. So their pollens here are rough and sticky. When the insect comes around, the insect unknowingly carries the pollen. And the pollen, the petals are actually arranged in such a way that there's no way you will get inside without carrying the pollen. So when the insect gets there to look for something, the pollen gets stuck on the back. It carries it unknowingly. As it's going, it gets to another plant. It drops it there. So that's the way it works. So their pollens are rough and sticky. And one thing again is this: they are relatively few. They are not much. They are not much in nature. They are programmed in such a way that there is efficiency. And so when the insect goes, before the insect will drop any pollen, it drops it at the targeted site. It is not just an insect moving without direction. They move with aim. So basically, they are relatively few. They are rough and sticky. While for wind pollinated, they are smooth. The surfaces are smooth. They are smooth. Take note, a pollen grain is actually yellowish in nature. It's a fine yellowish structure fine yellowish structure. You probably might have seen it before. So they are smooth and light, and they are numerous. Why are they numerous? They are numerous because they are going to be pollinated by wind. They are going to be pollinated by wind. And you know, wind, the efficiency, one of the best ways of actually making use of wind is to go en mass. You know, when wind carries large amount of substances, it carries them effectively. Unlike when it just carries one, the ability to carry that one is always much. So it probably might even carry it more than the recognized area. You might take it and drop it elsewhere, farther than the targeted site. But when they go en mass, it reduces the effect of the wind, and the wind carries them straight to the side. Now, one thing about this thing, it is programmed. It's just like, you know, when you study this, you're like, God, yeah, you're great. You just cannot hide it. So basically, they are smooth, light, and numerous. The stigma has sticky surfaces. The stigma is always the recipient. Whatever the insect is bringing for insect-pollinated flower is going to drop it on the stigma. So when the insect is carrying the pollen, recall that the pollen is sticky. When the pollen gets there, the stigma surface is also sticky. So when it gets there, it just goes. It stays there like that. So it's not going to fall off. It stays at the top because both parts are sticky. Now for wind pollinated, they have airy surface, airy surface, airy surface, airy surface. Now lastly, examples of insect pollinated flower are hibiscus. Hibiscus rosa sinensis. It's actually predominant in China. We have Delonis regia, flame of the forest, we have pride of Barbados, and so on and so forth. Now for wind pollinated flower, we have rice, Oryza sativa, we have maize, Z-maize. As a matter of fact, if you know you have a maize farmland at the back of your house, I would advise you learn to always close your mouth. You know, there are some people, they work this way, and this is how they work. Their mouths are usually open. Now, one of the effects is this. You know, maize is pollinated by wind. And so the wind might just carry the pollen, and you know, it gets to your mouth, and that's all. It joins your system, and both of you live happily ever after. And so it's been a nice time out with you. Again, we looked at the meaning, the types, the conditions, and the characteristics. A question will pop on your screen. Do the needful. I must commend you've been hardworking thus far, so just do the needful. Should you have any problem, go through the video over and over again. Peace out. Peace out.